Welcome to Trinath chemistry classes. In this video, I am going to discuss about intermediate second year chemistry topic, general principles of metallurgy. In this principles of metallurgy topic, this is my second video. In my first video, I have discussed about why we are studying general principles of metallurgy and the basic terminology present in this chapter, such as mineral, ore, gangue, and slag were discussed. Then I have discussed about some important ores of aluminum, copper, zinc, and iron, which are the part of the intermediate second year chemistry syllabus. In this video, I am going to discuss about concentration of the ore. In this concentration of the ore, I am going to discuss about leaching method. In my first video, I have discussed that in any metallurgical process, there are three steps. The first step is the concentration of the ore. And the second step is the conversion of ore to metal. And third step is refining or purification of the metal. In any metallurgical process involves basically three steps. One is the concentration of the ore, second one is the conversion of the ore to the metal, and third one is the refining of the metal. Means after getting the metal, we need to purify the metal. That is only the step, the refining of the metal. In my first video, I have discussed that why we are studying metallurgy. Why we are studying metallurgy? Because metals, most of the metals in the nature are not occurring in their native form. They occur in the compound form. So how to extract metal from their compounds? What are the basic principles involved while extracting the metals from their compounds? In that video, I have discussed about the difference between the ore and the mineral. Mineral is the naturally occurring compound of a metal. For example, if you take sodium is occurring as sodium chloride, sodium carbonate, sodium bicarbonate, sodium sulfate, sodium nitrate, and so on. All these are minerals. But from some certain minerals only, metal is extracted because it is economic, and you will get a lot of metal. For that, the industrially, we are not using all the minerals to extract the metals. The minerals from which ore is extracted, the mineral from which metal is extracted, we are calling it as the ore. In that video, I have also discussed about gangue and slag. What is gangue? The impurities. While extracting the metal, the impurities of while collecting the ore, some impurities are also present, such as sand. The impurities present along with the ore, we are calling it as the gangue. For removing the gangue particles, we are using some external chemicals. We are calling it as the slag. So to remove the gangue particles, we are adding some external substances. Those we are calling them as flux, and this gangue plus flux, we are calling it as the slag. So in this video, I am going to discuss about concentration of the first step, concentration of the ore. What is the concentration of the, what do you mean by concentration of the ore? The simply removal of the gangue particles from the ore, we are calling it as the concentration of the ore. Removal of the gangue particles from the ore, we are calling it as the concentration of the ore. Right here, various techniques are there. Various techniques are there for the concentration of the ore. For the concentration of the ore, the various methods are: one is hand picking method. Hand picking method. Second one is magnetic separation. Second one is magnetic separation. Third one is froth flotation. Third one is froth flotation. And the last one is leaching. So in this video, I am going to discuss about leaching method. I am going to discuss about leaching method. What is leaching method? Generally, leaching is a chemical method. Leaching method is a chemical method. It is a chemical method. For example, if you take this magnetic separation or hand picking or froth flotation, all are physical methods. But leaching is a chemical method. So what is the principle involved in this leaching? When we are applying this, we will apply this leaching method. If ore is soluble in a suitable solvent, and but not gangue particles, If ore is soluble in the suitable solvent, but not gangue, in that case, we will use this leaching method. Suppose some A ore is there. In this B gangue particles are there. Suppose ore is soluble in the particular solvent, some solvent, but not gangue. Then we use it to apply this technique, leaching method. Commercially, aluminum ore. We know that in my first video I have already discussed the important ores of aluminum or bauxite. The main ore of aluminum is bauxite. So this bauxite ore is concentrated by this leaching method. Aluminum ore, that is bauxite, is concentrated by this leaching method. So this aluminum ore, it is written as Al2O3.2H2O. This bauxite is aluminum ore generally contains or associated with oxides of iron, titanium, and silicon. What are the impurities present in the bauxite ore? The impurities present in the bauxite ore are oxides of iron, titanium, and silicon. So silicon oxides are SiO2 and titanium oxide, similarly Fe2O3 or Fe3O4. So here aluminum ore, bauxite contains oxides of iron, titanium, and silicon as impurities. So how they will do this leaching method for the concentration of the bauxite ore? In this method, what they does is the powdered ore is digested in concentrated NaOH, concentrated sodium hydroxide at 473 to 523 Kelvin and 35 to 36 bar pressure. So in this leaching method, for the purification for the concentration of the bauxite ore, whatever powdered ore is there, that is digested in concentrated NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure. So under these conditions, bauxite that is alumina is digested in NaOH and formed as a sodium aluminate. So when powdered ore is digested in concentrated NaOH. When it is kept in the concentrated NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure, what happens is this whatever alumina is there, Al2O3 is there, it is soluble in NaOH and forms as a sodium aluminate. Sodium aluminate. So it is formed as a sodium aluminate. So in this process, Al2O3 alumina is leached out as sodium aluminate, along with silicon oxides also. Silica also are leached out as sodium silicate. Sodium silicate and alumina as leached out as sodium aluminate. When this powdered ore is digested in concentrated NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure, what happens is Al2O3 is leached out as sodium aluminate, along with the silicon oxide also. Silica also leached out as a sodium silicate. It will go into the solution. And the other impurities leaving behind in the solution. Here, what is happening is when alumina ore is dissolved in solid plus 2NaOH. What is happening? Plus 3H2O. This is aqueous. What is happening is sodium aluminate. This is the aqueous solution. So in this leaching method, aluminum ore is digested in concentrated NaOH. Then what is happening is alumina and silica are leached out as a sodium aluminate and sodium silicate, but leaving behind the oxides of titanium and iron as precipitates. This whatever the filtrate is there, that filtrate is again the filtrate is neutralized with. The filtrate is alkaline in nature, it is basic in nature, and is neutralized with and so when this aluminum bauxite ore is powdered bauxite ore is digested in concentrated NaOH at 473 to 523 Kelvin and 36 bar pressure, what happens is alumina ore is leached out as sodium aluminate. And the other impurities such as titanium oxide or iron oxide leaving behind in the solution, as impurities. And along with alumina, silica also leached out as sodium silicate. And this sodium aluminate is alkaline in nature, and when it is alkaline in nature, basic in nature, and is neutralized with this whatever alumina and treated with sodium hydroxide, this is the solid, and here it is aqueous solution, 3H2O liquid, and we will get 2Al OH 4 times aqueous. This is sodium aluminate. It is soluble in NaOH. It is soluble in water or NaOH. Sodium aluminate. Here, this sodium aluminate is alkaline in nature, and when it is neutralized with carbon dioxide, and is neutralized with carbon gas, this alumina as precipitated as hydrated alumina. hydrated alumina. Hydrated alumina. And whatever previously I told, silicon oxide also precipitated as digested as a sodium silicate, but it is present in the solution only, and is present in the solution only. And this is dried, and you will get anhydrous alumina. You will get anhydrous alumina. Once it is heated, you will get anhydrous alumina. So the leaching method basically involves what is the principle involved in this leaching method? Ore is soluble in a suitable solvent, but not gangue. Then only leaching method is used. Either ore should be soluble in a suitable solvent, but not gangue particles. So generally, bauxite ore, what are the impurities present in the bauxite ore? The impurities present in the bauxite ore are oxides of iron, titanium, and silicon. Oxides of iron, titanium, and silicon. This bauxite ore is generally contains or associated with impurities such as oxides of titanium, iron, and silicon. This bauxite ore is digested in concentrated NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure. When this bauxite ore, powdered bauxite ore is digested in concentrated NaOH, aluminum oxide, that is Al2O3, we are calling it as alumina. Alumina is leached out. Leached out means it is going to the solution. It is going to the solution as sodium aluminate. Sodium aluminate. And along with this alumina, Al2O3, silicon oxide also. Silicon oxide, which is calling as a silica, SiO2, also leached out as sodium silicate. So now, what are the contents? What are the substances present in the solution part? One is sodium aluminate, and another is sodium silicate. Another is sodium silicate. And the other oxides, such as iron oxide or titanium oxide, are leaving behind in the as a leaving behind as precipitates. They won't dissolve, they won't digest, they won't leach out. That's why they will be present as some precipitates. The filtrate, it will be filtered, and the filtrate is further neutralized with carbon dioxide. As it is sodium aluminate is alkaline in nature. Sodium aluminate is alkaline in nature. It is neutralized with carbon dioxide to get hydrated alumina. This hydrated alumina is heated at around 1400 Kelvin, to get dry alumina, dry or anhydrous alumina. Anhydrous alumina. So, method involved in the purification of bauxite ore. So this is one of the important concept in general principles of metallurgy, that is concentration of the ore. So here this one is useful in objective point of view also. The impurities present in the bauxite ore are what? Dioxides of titanium, iron, and silicon. And how it is leached out? What is the principle involved in this one? The ore is soluble in a suitable solvent, but not gangue. Then only we use this method. What they does in this leaching technique, in this purification of bauxite ore, in the purification of bauxite ore, the aluminum bauxite ore is powdered bauxite ore is digested in concentrated NaOH at 473 to 523 Kelvin and 35 to 36 bar pressure. When this is digested, is mixed in the water, sodium hydroxide, concentrated sodium hydroxide solution. What happens is alumina, Al2O3, is leached out as a sodium aluminate along with silicon, also as a silicon sodium silicate. But other impurities are left as precipitates, or they won't react, they won't remain unchanged, and is they present as a powder only. And this the sodium aluminate is further neutralized with carbon dioxide, to get hydrated alumina. This hydrated alumina, when treated with, when heated at 1400 Kelvin, we will get anhydrous alumina. Anhydrous alumina. So this is the leaching method, which is important for IPE, intermediate public examination point of view. Thank you for watching. Please subscribe the channel, like the video, share and subscribe the channel. Thank you.